Congrats, buddy.
Let's look at the first example. Sketch the system of inequalities given below and shade the visible region. So here is our system of inequalities. In the first step, we have to make sure that our variables of y are positive. In this case, all of the variables of y are in positive form. So you can look at here, y is positive, here y is positive, and here y is positive. Next is we're going to determine whether we are going to use a dashed line or solid line by looking at the inequalities notation. So this is less than without the equal sign. That's why we're going to use a dashed line. Whereas for the second inequality, this is greater than or equals to with the equal sign, then we're going to use a solid line. Same goes to the third inequality. This is we have the equal sign. That's why we're going to use a solid line. Next is we let the inequality as an equation. So for the first inequality, x plus 1 squared plus y minus 3 squared now is equals to 16. So this is the standard form of a circle. So first what we have to do is we try to find the center of the circle. So by letting x plus 1, so we let x plus 1 equals to 0 and y minus 3 equals to 0. So x is equals to negative 1 and y is equals to positive 3. So our center of the circle is equals to negative 1 and 3. Next is the radius. So for this is our radius, r squared is equals to 16. So r is equals to 4. So we have for the first equation, we have the center at the coordinate of negative 1 and 3 and the radius is 4. Next we move on to the second inequality. So we let y is equals to x. This is an identity line. So by using the table of values, here when x is 0, so we can substitute here, y also equals to 0. When x is 2, when we substitute into this equation, y also equals to 2. As a references, I rewrite the system of inequalities and the information from the first and the second equation. Next, let's look at the third equation. X plus y is equals to 4. So this is a linear function or linear equation. So we can try to find the x-intercept and y-intercept. So at x-axis, y is equals to 0. So from here, x plus y, y is 0, is equals to 4. So now x is equals to 4. So at y-axis, x is equals to 0. So substitute into this equation, 0 plus y is equals to 4. So y is equals to 4. So now we have the intersection at x-axis and y-axis. Based on the information that we have on the left hand side here, so now I try to plot the graph. So let's look at the first equation, which is the equation of a circle. So the center is at negative 1 and 3. So here is the center. Since the radius is 4, so here are the points on the border, where each of the point, the distance for each of the point from the center is 4. So you can see the distance here is 4 units. So by connecting both points, and we are going to use a dashed line, so we have the graph for the circle. Next is the identity function, y is equals to x. So when x is 0, y is 0. So here is the point. When x is 0, y is 0. The second point, when x is 2, y is 2. So when x is 2, y is 2. By connecting both points with a solid line, why we are going to use a solid line? Because of the inequality sign. So here is the solid line. We have the graph for y is equals to x. Finally is the third equation, x plus y is equals to 4. At x-axis, so here is the x-axis, y is equals to 0. So here x is 4. So we have the point x is 4. At y-axis, x is 0. We have y is equals to 4. So y is equals to 4. By connecting both points with a solid line, because of the inequality sign is we have the equal sign in the inequality sign. So we have a solid line, x plus y is equals to 4. Next, we try to shade the region. For the first equation, which is the circle, this is less than. So if less than, we're going to shade the region inside the circle. So here is the first shaded region. Next, y greater than or equals to x. So here is the line, y is equals to x. Since this is greater than, so we're going to shade the region above the line. So here is the second region. Finally, the line for x plus y less than or equals to 4. So here is the line for x plus y equals to 4. For less than, so we're going to shade the region below the graph. So below the graph. So next, what we do is we try to identify which is the overlap layer or the overlap region. So you can see here is the region where the shaded region is overlap. So here will be our shaded region or the solution for the system of inequalities. Here is the overlap region for the system of inequalities. Next, we're going to validate this shaded region. First, I'm going to choose a point from this shaded region. Let's say the test point is -3 and 2. So here is the test point, -3 and 2. So we're going to substitute this test point into the system of inequality. For the first inequality, when x is -3 and y is equals to 2, so we substitute into this inequality, x is -3, y is 2. So -3 plus 1 is -2, -2 squared is +4. So for this part, 2 minus 3 is -1, -1 squared is +1. So 4 plus 1 is 5, so 5 is less than 16. This statement is valid. Next, we go to the second inequality, y greater than or equals to x. So y is 2, x is -3. Again, this statement is valid. Now is the third inequality, x plus y is less than or equals to 4, where our x is -3, y is 2. So -3 plus 2 is -1, and -1 is less than or equals to 4. Again, the third statement also valid. So from this test point, so we can validate that this shaded region is the solution for the system of inequalities.